Welcome back, everyone. This lesson covers Activity 2, 1 through 8 from the AMDM lesson on future value of an investment. Amanda is analyzing how to invest $500. She is considering the two investments described below. We have a savings account and we have a certificate of deposit. It's also called a CD. For the savings account, Amanda is considering an account that pays 3.75% interest compounded annually. Let's go ahead and calculate that. In the table, we have the savings account over here on the right. The beginning balance is $500. The interest is 3.75%. So if we were to multiply this 500 times 0.0375, we would get $18.75. So that would be the interest earned. Now the ending balance would simply be the 500 plus the interest earned. So 500 plus 18.75 is $518.75. Now for the beginning balance on year 2, that would be the same as the ending balance of the previous year. So we would just rewrite the 518.75 here at the start of year number 2, and then we would multiply that times the interest rate of 0.0375 again. So now 518.75 times 0.0375, that gives us an interest amount of $19.45. Now we'll take the 518.75 plus the interest of 19.45, and that would give us the ending balance at the end of the second year. So adding those two amounts, we get $538.20. Now take this amount and transfer it to the beginning of the next year. That would be the starting balance. So $538.20. Now we'll need to multiply that $538.20. Let's see, here we go. So 538.20 should be multiplied by the interest rate again, which is 0.0375. And that's going to give us a total of $20.18. Now, to figure out this ending balance, we simply take the beginning balance here plus the interest. So we'll add these two amounts. Adding those two amounts, we get $558.38. This ending balance at the end of year 3 also becomes the beginning balance of year 4. So transfer this amount over to here. So now we have $558.38 at the beginning of year 4. And then we'll multiply that by the interest rate. So we take 558.38 times 0.0375, and that's going to give us $20.94 for the interest. Now we'll add the beginning balance here plus the interest, and that'll give us the ending balance here. So adding those two amounts comes out to $579.32. And as we did before, the ending balance of year 4 also becomes the beginning balance of year 5. So we transfer that over. It's $579.32. And then to get the interest, we'll multiply this $579.32 times the interest rate. So 579.32 times the interest rate of 0.0375, and that comes out to be $21.72. Now, to get the ending balance here, we simply take the beginning balance plus the interest, add those together, and that's going to give us $601.04. So this is going to be the ending balance at the end of 5 years, and this is for the savings account. So again, at the end of 5 years for the savings account, we'll have $601.04. All right, now let's talk about the CD. The certificate of deposit, the way that works is we have a simple interest of 4%. So man is considering the CD that pays simple interest 4%, and that's annual interest for 5 years. So the way we calculate that is we have a beginning balance of $500 as we did before, and we'll multiply that by the interest rate of 4%. Now that is 0.04. 500 times 0.04 is $20. So to get the ending balance, we would simply add the beginning balance plus the interest. So 500 plus 20 is $520. Now let's transfer the ending balance here to be the beginning balance of the next year. So we'll just rewrite $520. Now, simple interest is only calculated on the beginning balance of 500. So, again, you take the 500, not the new amount, but $500, the beginning balance, times 4% again, which is 0.04. So multiply 500 times 0.04 again, and that's $20. So that means we add the beginning balance of year 2 plus the interest for year 2, and that gives us the ending balance. So that's 520 plus 20 is 540. We'll transfer the ending balance here to be the beginning balance of year 3. So that's 540 is the beginning balance. The interest is going to be the same interest as before. It's still going to be 500 times 0.04, which is $20. So we're just going to add another $20 here. Add the $20 to the 540, and we get $580. So that's $560. So $560 is the ending balance here, which also becomes the beginning balance of year 4. So we have 560 as the beginning balance. Interest is exactly the same as it was in the previous years, $20. So that's $20 there. Add 560 plus the 20, and that's $580. $580 is the ending balance of year 4, which also is the beginning balance of year 5. The interest is $20 again. Adding the interest plus the beginning balance, now we have $600. All right, so if we choose the CD, then we would have $600 at the end of year 5. All right, question 2. If Amanda is using this investment as an emergency fund, in which should she invest? And explain. All right, well, first of all, there's something about the CD that we should know. The CD must be held until the date of maturity. What that means is, if you have a CD for 5 years, then you cannot withdraw any money out of that CD account until the 5 years is up. So the CD must be held until the date of maturity, at which time the original money deposited may be withdrawn. So she would have to wait the full 5 years before she could withdraw any money from that account. So, if Amanda is using this investment as an emergency fund, in which should she invest? I would say that Amanda should invest in the savings account, not the CD, because from the savings account she could withdraw money anytime if needed. All right, here's problem 3. Based on the processes that you use to fill in the spreadsheet in question 1, write a function model to model each investment. Let y represent the value of the investment at the end of any year X. All right, so let's start with the savings account. With the savings account, we were multiplying by 0.0375 every year. Now, you might recall from previous lessons that if you're multiplying by 0.0375 every year, you always have to add that to 100%. So think of it as starting with 100%, adding 3.75%. Well, that's going to give you 103.75%. Then you're going to convert that to a decimal. So you'd move the decimal point over 2 places, and it would end up being 1.0375. That's going to be our multiplier. So the equation would be y equals the $500 we start with plus the multiplier of 1.0375, and then that would be raised to the power of x, where x is the number of years. All right, now what about the CD? For the CD, you remember we were just adding $20 every year. See, down this column, you just kept adding $20 to the previous year. So because you're adding, we have a linear equation. So that equation would be y equals the 500 that we start with plus the adding $20 every year times x years. So that equation is 500 plus 20 times x. Question 4. What types of functions did you use to model each investment option? How are the functions related to the type of interest earned in each option? Well, we talked about this already a little bit. The savings account earns compound interest and is modeled by an exponential function because we multiplied by the same amount, and that was 1.0375 each year. The CD earns simple interest because we were adding $20 every year and is modeled by a linear function. All right, question 5. Amanda has decided to keep the investment until retirement, 40 years from now. Assume that she can invest in the same CD or savings account at the same rate for the life of the investment. Use your graphing calculator to graph both functions. Describe your axes and scaling, and sketch your graphs. All right, so this part is really done for us already. We have the graph of the CD, which is linear, and then we have the graph of the exponential, and we see that that curves upward. All right, problem 6. Compare and contrast the graphs of the two different functions. Explain what you see in terms of the function rules and the tables. Let's look at the two graphs. The savings account, we see that it grows, but it grows at an increasing rate, getting steeper and steeper. Whereas the CD, it also increases, but it is increasing at a constant rate. So we can simply say the graph shows that the savings account increases at an increasing rate, while the CD increases at a constant rate. The function rule for the savings account is an exponential function, while the function for the CD is a linear function. Number 7. Why is there a difference between the two models? Explain your answer using the information from the tables, graphs, or function rule. Well, we can say the rate of change is different in the two functions. For the CD model, the change is a constant addition from one time period to the next. In this case, $20 is added to one value to obtain the next value. For the savings account model, the change is a constant multiplier from one time period to the next, in this case, 1.0375. This produces an increasingly large amount for each time period to be considered. And here's question 8, reflection. Which investment should Amanda use, the CD or the savings account? Well, let's take one more look at the graph. As you can see, the savings account, as we mentioned before, the savings account increases at an increasing rate. So at the end of 40 years, it would be worth more than the CD. So we can simply say that Amanda should invest in the savings account because it is worth more money in 40 years.